I successfully built a program that operates this batch simulator, but there were a few problems with it. It worked, but from a human factor standpoint, there were some problems like when I hit the stop button, pumps didn't stop, and so forth. So I'd like to fix all of that now. So let's see what we can do to fix all of that. So one of the easiest things to start with is the stop button. If we add in another rung, we can make other things happen when the stop button is pressed. For example, if the stop button is pressed, well, what does that mean for the stop button to be pressed? Well, when it's not passing power, right? It is a normally closed switch. And so normally it passes power. When it's pushed, it doesn't pass power. So when it doesn't pass power, that's when I want to shut things off. So let's see, what all would I shut off? Well, certainly the mixer, all of the pumps, and the heater. All those things should be shut off if the user presses the stop button. So let's put a bunch of unlatch instructions on this rung. And we want to unlatch all the pumps, certainly. Let's copy this, make our lives easy, paste left, move it down. We'll be consistent. Let's see, paste left, move that one up. We'll make it pump number 2. So this will shut off pump number 1, 2, and 3. We also want to shut off the heater and the mixer. So let's see, if we were strictly to go in order by the addresses, I guess that would look the nicest. So let's see. Just trying to save myself some time here by pasting an instruction and then giving it a new number to reference the things that I actually want to turn off. Let's see, that would be this one I want to move down. And I believe that the last item, the heater, is on bit 4. There we are. So whenever the stop button is activated or pressed, what will happen is all of these 5 things will be shut off. Well, that's a good thing. That way when I hit stop, the machine stops. That's what we want. Now, what else might we want? Well, what about the lamps? Well, I could add in an instruction to make one of the lamps work. For example, what about the idle lamp? Well, when is the machine idle according to the operator? I guess when it's off. So really it seems like that the idle lamp should be the opposite of the run mode. So if I put, let's see, run mode as a condition, and I invert that condition, and then put that out on the idle lamp. Let's name it. You may think of something more creative to do with it, but to me that's what it means. The machine's just idle when it's not running. And even if it's just mixing, or if it's just filling or heating, it's not idle, it's running. Maybe you want idle to be that the reaction's taking place, or that there's basically no flow. Well, you could include that as a condition, right? Instead of having run mode be off as your condition, you could say if pump 1 is not running, and pump 2 is not running, and pump 3 is not running, then apparently the machine is idle. In other words, there's no flow. And if that's what you intend, that's fine. It's up to you. I've decided that for whatever reason, the idle just means the machine's not doing anything at all, so that's the opposite of run. So that should take care of the idle lamp. Well, what else could I do? Well, what about this? What about if I want to display how much stuff is in the tank? How could I do that? Well, let me go to the bottom of the code. It really doesn't matter where I add most of these things. They're not order dependent, and so what I'm going to do is say if either one of these flow meters has flow, then I want to count that flow. So basically what I'm saying is if we're ticking volume in for part 1 or for part 2, I want to count that. So what I'm going to do is use another counter to count up, and I can't use any of the counters I've selected so far, so C colon 2. Don't believe I've used it. Yeah. Now I'm not going to give it a preset because I really don't care what this counter goes to. Its purpose is just to keep track of how much volume is in the tank. Now I'm using this as an example because I can also use a countdown counter. Now this counter is going to subtract, but it's going to subtract from the exact same count. Let me explain. I didn't mean to cut that. Let me put it back in. There we go. So when flow meter on I colon 1/7 is giving us ticks, that means that volumes are flowing out of the pump, however much volume this thing measures. I'm going to assume that they have the same volume size, right? So one tick on this flow meter is the same as on this flow meter, which is the same on this flow meter. And from playing with the simulation, I'm sure that's correct. But I'm going to reference counter 2 again. You say, wait a second, I thought you had to use a different counter. Well, really, these instructions are not the counters themselves. The counters are the bits and the bytes in memory. So if I go to the counter file, really the counter exists here. It consists of flags that indicate its status. It consists of a preset value and an accumulated value. All I really care about is this accumulated value. So really that is the count. These are instructions that either these instructions affect the accumulated value, but the other bits are bits that are automatically set or cleared by the operation of the counter, and I can reference those in my code, as of course I've already done. For example, when the counters are complete or done, the done bit is set and I can use that. So what will happen is if either one of these flow meters have flow going in, the count of volume in my tank will increase. But if flow is going out, the count of volume will decrease because this instruction makes that counter increment, this one makes it decrement. Okay, so now I've got it. Basically it exists in the accumulated value, and this accumulated value and this one are the same accumulated value because it's the same counter, just one makes it go up, the other one makes it go down. Okay, how would I then display it? Well, this display is what's called a binary coded decimal display. If I were to copy the accumulated value, which is in just straightforward binary over here, it wouldn't look right. You might want to try that and see what happens. Instead, what I want to do is convert it to a different format called binary coded decimal. And so to do that, I'll have to use a math instruction. It's a compute math. There's two instructions for dealing with binary coded decimal input and outputs. One is to convert from binary coded decimal to binary. That's FRD. The other one is to convert to binary coded decimal, and that's the one I want so I can actually display the current count on this binary coded decimal display. Now that display is on output word 4. So I'm going to take the results of this conversion and put it out on output 4. So what am I converting? Well, I am going to convert C2's ACC value. You see the ACC value, this that I've typed here, references this number right here. So as counts are added up by the counter, it goes into the accumulated value. So I can reference that accumulated value. It's just memory. It's literally, I keep closing it, but it's literally right there. That is the word that gets added to or taken away from by the count up and count down instructions. And that is the name of the word that I'm referencing here, C5:2. C and 5 are redundant. They're the same thing. It's just counter file 5. :2, that means word 2. Here we are. And the accumulated value, the 16-bit word that represents the count in the counter itself. So that count is going to, strictly speaking, be in binary. And I can't just throw that out onto this display. It won't look right. So I have to convert it to binary coded decimal. That's what this instruction does. Notice there are no conditions leading up to this. In other words, this is something that is simply going to happen automatically every time it's scanned, and that's fine. That should work for what I'm doing. Now, there's an interesting effect that happens if I do this where I'm counting here. For some reason in this simulator, you can end up putting in 300 units, but it's actually 301, and then when only 300 come out, you still have a volume of one count in the tank, at least according to this counter. And so slowly but surely this this display creeps upward. It'll go to 301, 302, all the way to, I let it go and it went all the way to 309 after about an hour or so. Now that's not good. If I've emptied out the tank, there should be nothing in it. So I'm going to use the reset command again. And if you think about it, once the low level switch goes off, that means there's nothing in the tank. So at that point, I would like to just go ahead and reset the accumulated value that's in counter 2. So in other words, if the low level sensor is off, which means there's nothing in the tank when that happens, then I want to use a reset instruction, and I want to reset counter 2's accumulated value. Okay? Now, there's another lamp. There's the full lamp. Now, notice that I'm not filling the tank enough for the high level switch to come on. So when is the tank full? Well, it's full when I put in however much I plan to put in, right? So maybe I could add in another rung to drive that lamp. So let's do that. Let's reference the lamp itself. Okay, so the full lamp, I think I named it at one point. No, I guess not. Let's edit symbol, full lamp, or full indicator, whatever you want to call it. When is the tank full? Well, the tank is full when it has 300 units of volume in it. So that's a comparison, right? As a matter of fact, now that I've got a count of how much volume there is in the tank, couldn't I compare to that count? Now, it's possible that the volume of the tank will go above 300. So I'm going to say if the counter C:2.acc, if that count is greater than or equal to 300, then turn on the full lamp. So I've made several changes. Let's download this, and let me make sure we're in the right mode. I need to start with all of the bits off because, again, this is a, yeah, that's what I was afraid of. Some of them are on. There we go. This is a sequence machine, and I have already reset the simulation, but just in case, let's do it again. Download. Are all of our timers and counters intact? Yes. Oh, by the way, there is another bug I want to tell you about Logix Pro you have to be careful about. I don't remember the exact sequence of events. I'll try to remember it and include it in the next video, but there's certain things you can do, and it'll erase all of your notes. All of these little nice notes that tell you what's what. It can erase all or some of it. I've seen both. So another bug in Logix Pro, but I'm sure it'll happen to me at some point and I'll remember. It seems to me that the safest thing to do is always download before you run. But anyway, there we go. So right now the system is in idle. That makes sense. I'll start the system. I think I'll start the system. There we go. So now it's in run mode. Why is it not filling? Let's see. It's trying to heat now, but that doesn't make sense. I haven't pressed the stop button, so that doesn't do anything. Run mode lamp made idle go out. That's good. According to this, it says that we're in which step? Well, step 1 it says is done, step 2 is done, but that doesn't make any sense. Low level, it says, is not true, so that should have... Here, let me reset the bits again. I'm actually going to bring that up. That helped last time I had a problem like this. So let's download. And I think you have to leave the table over here if I remember right. And then run. There we go. Okay, so none of the bits are on. If I hit start, well, come on, don't get rid of my table. It very quickly goes to 3. How on earth is it doing that? Okay, so why did it not work? Oh, my counters are done. I forgot to reset timers and counters. Okay, so simulations, reset simulation, and reset timers and counters. Yes, reset all the timers and counters. Okay. So now, yeah, reset my bits. Let's download and run. And now start. There we go. So now it's filling as I expected. I'm going to take the thermostat down. I had it set to 80. There's no need for it to go up that high. That'll just take a long time. We'll make it go to, say, I don't know, 40 degrees or so. That's what the simulation was set at by default. And okay, so now our heater's on after the initial mix. Temperature's coming up nicely. Notice that the tank indicator says that it's full. Oh, and our binary coded decimal display is working, telling us that we have 300 units of volume in the tank. Okay, we'll let it go through one cycle. So this should be the post-heating mix to finish the reaction. There we go, it's pumping out. And our level in the tank's going down. That's good. Okay, so now it's filling up. Now remember before, the problem was when I hit stop, it didn't really stop. Now it does, see? So when I hit the stop button, it stops filling. If I hit start, it doesn't work. Why? Well, when I hit the stop button, what happens is all of the run modes are shut off. And the problem with that is that can get the system out of sequence. It can make the system go to it or think that it's on a step that it's really not. And so that sometimes can mess up a sequencing machine. Now, the assumption is when you hit the stop button that there's a reason for hitting it, right? That you're not just shutting the machine off so you can take a lunch break. You're shutting it off because it's overflowing or something's going wrong. And so the assumption is that you're going to clean things up to make it work again. Now, usually these simulators reset where you can see it. It has reset, it's just not updating the graphics. And so if I reset timers and counters as well, that's done. So I've actually reset the whole thing. But one thing I would like to do, rather than having to go and reset the timers and counters and reset the bits and everything, what I'd like to do is make it so that whenever the start button is pressed, let's see, do I want to do that? I was going to say whenever the start button's pressed, I just go ahead and reset all the bits from the very beginning and all of the counters and all the counters accumulated values. If I did that, and what I'm worrying about is if I hold the button down for some time, I'll be forcing all of these bits to remain off. Since low level is not true, the pump would come on, but I'd hit, let's see, I'd be hitting the start button, so it should be able to run. Eventually I'm going to release it. I'm afraid that if I hold down the start button, it's going to cause a problem. I think what I'll do is have it set up so that when I hit the stop button, I'll reset one more thing. I may as well put it there instead of at the start button because I hesitate to have the start button reset all the bits. So all I'm going to do is the exact same thing I did at the end of the sequence. I'm simply going to reset the entire word of bits. So let's paste right or left, doesn't matter. I'll pull it down here so that it's clean. There we go. So I'm just going to reset all of those bits, and that way the system's ready to be cleaned up and started again. So that was one thing I wanted to do, is reset the bits so that it goes back to the first step. I felt like there was something else I wanted to do along the way. Oh, I wanted to also reset the counters. So I guess rather than having the start button reset the count, I guess I could do that. It really wouldn't matter. It's just that, again, if the operator holds down the start button, they could force the counters to be reset constantly. We could get to a point, well, in fact, that would cause trouble because that would reset the counter even though there's flow coming in, so we wouldn't be able to track how much flow comes in. That's not good. I think I will reset the counters here also. So I'll just OR around this twice more. And I'll copy the instructions I have down here for resetting the accumulated value. And clean things up so it's all structured the way I like it. Paste left is fine, doesn't really matter. Oh, that's not what I wanted. There we go. Okay. So now, let's see. Let me download this. I'm going to reset the simulation, and I'm not going to reset timers and counters. Notice I have the habit of hitting download before run every time. Instead, what I'm going to do is hit stop. That should reset all the bits, should reset all the counters, and now when I hit start, it should work. There we are. So we've added some things to this program. Let's make sure it still goes through an entire cycle and that I haven't messed anything up. We've added some features where the stop button actually stops things. That's probably a good feature to have. We've made all of the lamps work and indicate things. I haven't used this enter button for anything. I suppose I could. I haven't used the mode button for anything. And over here is where you would set the probably how much you want to put in the tank or something like that. I haven't used that either, but there are ways to do it. If I wanted the same ratio between fluid 1 and fluid 2 from the two pumps, I could use a math instruction to scale the amount that goes in from pump 1 and pump 2. So I could scale the set point, I could put it in memory, and once, rather than having a preset of 100 in one counter and 200 in the other, I could actually calculate those presets and overwrite them in the .pre value of the counter itself. I won't bother demonstrating that in this solution, though. It's been long enough. And I think that's everything. We're done. So I'll save this as a new file. And remember, it doesn't matter if I hit File Save or just a little diskette. It'll do a File Save As. And I can save this as version 2.